Sarah Jones with Jones Farms Organics, and we're located in the San Luis Valley. And we are a 5th and 6th generation organic regenerative family farm.
Hi, my name is Clark Harshbarger. I'm the Director of Stewardship with Matt Agriculture, and today I'm in the San Luis Valley here in Colorado on Jones Farms Organic. And we're going to talk a little bit about soil health and how the Joneses are using the principles of soil health, and particularly the principle of diversity, to make their system work both economically and ecologically. So here in this field, they're planting oats. They're harvesting the oats for a hay crop, and over here they have a cover crop. And so let's walk out in the cover crop, and we'll talk a little bit more about what we can see out here and what we can find. So all right, we have a diverse mix here. We have some radish, we have some rye, we still have some green radish growing here in the bottom as well. Cover crops are so important because they add diversity to your rotation, and it's so crucial to the San Luis Valley because they're on limited water. So the irrigation that they receive can be distributed by 3/4 of their circles, which make up about 120 acres, and they can use a whole quarter of their land to basically give back to the land, grow a diverse population of plants like this, and then save water. And so they can target the other portions of their circles and allocate their water budget on their cash crops, and then just use a couple different waterings to get a biomass here. Then they can also in turn use this for grazing, incorporating livestock in their system. So let's dig a little hole and see how the cover crops are, the diversity is affecting the soil health here. It's a little dry because they haven't watered, and what water is out here, the plants are utilizing. So quickly here you can see the rye plant. It's tillering, and down here in the bottom it's starting to get some new growth for its fall growth, and then this was the growth that it put on during the summer months. And you can see its roots are very fibrous, and so they create air spaces for water to infiltrate and release different sugars that feed the microbial populations. If you look at these radishes, these are the young ones that are re-establishing. The radish has a completely different root profile, right? And so the diversity, you have diversity in the architecture of the leaf between the radish and the rye plant, and then you also have a diversity in the root system. So these fibrous roots versus a taproot, and the taproot can go down once it's more mature and break up plow pans and create a coarse pathway for water to enter. Both of these are palatable for livestock. Both of them are still photosynthesizing, pulling carbon dioxide from the air, turning it into sugar and feeding the plant, and then 20% of it the plant leaks out to feed the soil microbes, and they exchange those nutrients and sugar for food that the plant needs to be able to basically have its immune system strong and to be able to have the diet and nutritional needs for the livestock that will be grazing. So there's another thing that they can do is when the cattle out here, this biomass will be trampled down, and it will cover the soil and armor it and keep it in place. So you can see here there's different residues, but as these get laid down from snowpack or from livestock, it's going to create an armor. And so the different types of lignous tissues will stay and be able to break down over time. This here is an oat plant right here. Oat plants are one of my favorite cover crops because they're what we call heavy feeders, or heavy excretors, I should say. And so oat plants, when you look at their root system, typically the soil will stick because the oat is, pushing out so much sugar, and you'll get these phenomena they call rhizosheaths. They look like dreadlocks in soils, and that's because the oat is pumping out so much sugar, it's actually sticking together just in and around and creating microhabitats. And so if I peel this back, you can see a perfectly live white root right here where the soil has been kind of armoring and protecting. And so inside of these rhizosheaths, you'll find 10x amount of microbial populations than if we were just to move 1 inch away in the soil profile, because the habitat is being richly fed with different, like I say, carbohydrates that are consumed by the bacteria, and then the protozoa eat the bacteria, and the nematodes can eat both protozoa, bacteria, and each other. And so one way that you can turn these cover crops and use these soil health, use cover crops as a practice in a soil health system, is you can utilize this, to help save moisture and target your cash crops. So you're basically using this to have a win-win. It's saving you moisture on this percentage of your circle while it's also feeding the soil microbes and storing carbon and other nutrients in your system. Another way is that they can utilize this for a forage crop. So it's very minimal resource, very minimal management. You just plant it, let it grow, water it a few times, and then they can use this as a forage base and rent this out for $15 or $20 an acre and recover some of the seed cost. Then the livestock is going to turn over some of the nutrients. It's going to fertilize it with manure and dung, and then the hoof impact is going to press this down and armor the soil coming into our spring season. And so there's a lot of ways that you can utilize creativity in your rotation to give back to the soil, promote healthy soils by disturbance, minimizing your disturbance, and then timing the disturbance as you go into your next crop. Potatoes are the cash crop in the rotation here. It's a very intense crop, and so they're using the cover crops to actually build back the soil as much as possible, and then they'll follow this crop with the potato crop. So it's a way to basically balance some of the give and take in the soil health management system.